lecture. So as you remember, we started the course with talking about the methods of data collection, data sources, methods for checking data for quality, for outliers, for suitability for a particular analysis. Then we talked about things that are much more simple. So we talked about, how to test if the two variables are related to one another, how to test if two variables are different from one another. And so those are relatively simple things. And in most cases, you can kind of get the general idea even by looking at simply, frequencies, averages, percentages, and things like that. And you can use more sophisticated techniques like regression or correlation, as we looked at. But, basically, as long as you see, some mean differences when you group your data, you will see the answer. Now, we are getting now into much more complicated territory. And so let me share my screen here. So we will talk now about methods that are much more complicated, and for that matter, also much more powerful. And so it is almost a shame that I will try to cover these methods in literally 1 hour, where I kid you not, I took literally a separate course on each of these methods. Like I took a separate HLM course. Well, actually for HLM, I got the textbook and kind of self-taught myself. But I had a whole separate course, for example, on structural equation modeling. And so here today, we're going to cover that in like 20 minutes. On the other hand, the goal of the class is not to explain how this methodology works. So I will not be giving you the formulas. I will not be explaining the actual math behind it or how to interpret the statistics and, whether or not your results are significant, but rather talk more about in which situations each of these methods is suitable, as well as which situations require some of these methods. And so it's more about the selection of the appropriate method and giving you the readings or links to more information so that if you need it, if that's your situation, you know what to look for, it exists, and where, what to read to familiarize yourself more with the methodology. And if you remember, or if you had a chance to look at the list of readings for this one, so we're getting into territory where there are more readings, they're much more technologically advanced, so to speak. So you have book chapters, but you also have dedicated papers that talk specifically about how, for example, test moderation, mediation, how it works. So again, you don't have to read it right away. You don't really need it, to know it by heart for the course to pass or to pass the course. But I provide them if you want to learn more, if this is something you may be using either in your dissertation or upcoming studies. And so if you do, then you have the readings where you can sort of teach yourself, if you don't know yet, how to do it right. And so we'll talk about moderation and mediation first. So moderation, again, sounds very familiar. You probably know what it is. I'm sure it was covered in the courses you took before, but let's take a quick look again, just in case you missed something or you don't fully understand what it is. So for example, just a couple of sample research questions. Let's say you want to know if GPA affects performance, right? So if you just simply want to look if there is the correlation between the, let's say, university or high school GPA and on-the-job performance, you know how to do it. You would just do simple correlation or maybe a regression analysis. But if you wanted to know if this effect is stronger for men versus women, so maybe GPA is more predictive of performance of men and less predictive of performance of women. So then it becomes more interesting. And in theory, you can just split your sample into men and women, calculate the two correlations, and then see if they are different. But there are sort of better ways to do it, and it would be through moderator analysis. Plus, again, if you do it for men versus women, relatively easy if you simply split the sample into two parts and then run the correlation for one versus the other and see if there is a difference. That's good enough. But what if you wanted to see if it applies to, for example, age or years of work experience? And you have people with anywhere between 0 to 25 years of age or work experience. Then it becomes more problematic. Then you have to split it, like in 25 groups, or have, like chunks of 5-year, per group. So that's where it becomes a little bit more problematic. And so there are better ways to do it with sort of one simple, easy, elegant test. Likewise, for example, does the GPA affect performance? Does the effect of GPA on performance increases with years or decreases with years? As I said, is the effect getting stronger for older people or more tenured people? So good question and not so easy to answer. All right, well, let's do it together. So let's answer this question together. So does in your opinion or in your experience, do experienced workers perform better? So do workers with experience kind of work harder, so to speak? What would you say without any analysis? Do they work harder or not?
No.
Do they work harder or perform better? Sound like two different questions to me.
Yeah.
So how would you go about answering this question? So I want to know if people who have more experience, so those who, let's say, work for 20 years at the company, are they putting in more effort than those who are newly hired? And so how would I know that?
Regression.
Okay. What is your expectation in this case? Would you say that they are or not necessarily?
I'd say they are.
No.
No.
More
They're too
experience leads
comfortable.
to higher performance.
Yeah, I agree. You're higher performance, but they work less for that performance.
Yeah, I don't know if, so what I see on the screen says perform better, but what you're saying is work harder.
That's a very good differentiation, but I still didn't hear the kind of the magic word, the one that a good answer would start with, would begin with. And the magic word would be probably, well, it depends. It depends on, you know, what kind of job we are talking about, what kind of company, what kind of people, or what performance means. Is it just simply working longer hours, or is it something else? So I found a data set. I'm not sure how real it is or made up. But let's take a look at, you know, using a real data set that, you know, perhaps would be usable. So, but in any case, how would you test this relationship? So let's say you have a way to measure both performance and experience. So how would you go about testing this relationship?
A survey?
What would be the sort of survey questions or variables that you would try to measure?
How long you've been in the space? Have you worked for the same manager for a while? How many hours do you work? Do you consider your compensation fair?
Yeah, exactly. And in fact, that's much more, Joe, than needed. So let's say in this case, we have two magic, you know, variables that fully capture experience, let's say years of work experience, and performance, whatever that might be, effort or hours worked or whatever other ones. And so we would collect the data, and then we would just simply look at the correlation between the two variables, right, in the simplest form. So let's try to do it. And here is the data from my real data set, data file that give us this correlation. So here you have the correlation bivariate, and here you have also a regression analysis with only one predictor and one outcome. So looking at these data, that's a printout from Stata, what would be your conclusion?
That it's minus adjusted R square, which means that it's this potential group is not.
Well, the minus part, I don't think it tells us much other than that both R squared and adjusted R squared are basically zero. And so
Right.
the correlation is -0.005. So what does it tell you? So what numbers would you be paying attention to? Like I would look definitely at this number here. So what is it, like how strong is this correlation in your opinion, given that we have 60 observations?
Weak.
Basically
It's
zero,
none.
right?
There's
Absolutely no
none, yeah.
relationship. And then I'm looking again at R squared, again, zero variance explained essentially. And I'm looking at the coefficients, very, very small. And the p-value, it's not even close to 0.05. It's basically close to 1. So no correlation whatsoever, right? So now let's take a look at the data. And I think I messed up my data file. Let me redo this. Not messed up, so the problem happened. That's my, I think this is good enough, but I was playing with the raw data, and I think this one is not a picture, but an actual Excel file linked to the original file. And I think when I made some changes in the data, it just basically made the changes in PowerPoint. So Microsoft Excel was, Microsoft Office, the different programs communicated with one another. But even looking at this, whatever that is, does it look like there is a relationship here?
No.
No, and it's not, yeah, this is the original data file. So it was supposed to look like this, And I even drew the regression line, which you can see is basically 0, and you have the confidence interval. So no relationship whatsoever, right? Now, what I did in my next relationship is I mapped the data, or I added one more variable to the mix. I added the difficulty of the task to the mix. And so on this chart, so it turns out there were 2 different tasks that my sample worked on. Part of the sample worked on, or one of the tasks was an easy mundane task, and the other one was a difficult and challenging task. And so these data points, when you have 0 by the data point, that means that it was an easy task. And when you have a difficult data point, you have a 1 by that task. Do you see any like picture emerging here?
Absolutely. It's very
So
clear.
what does it look like? Because it's still, I mean, these are still exactly the same data points as here. So, but are you seeing some sort of relationship going on here?
The ones go up and the zeros
But
go
in
down.
fact, yeah,
Very
it's a
good.
1
So
and
it
a
seems
negative
like
1.
there may be some moderation effect going on here. And sure enough, I ran the regression one more time, this time separating it into kind of, to better show into relationship between performance and work experience for easy tasks, and the relationship between performance and work experience for the difficult tasks. And so what can you tell based on this graph?
It depends on the difficulty of the task.
So going back to my original question, so does experience predict performance?
Yes,
The
How
easy
exactly?
worse, right?
it does, but you have to know what other factors are involved.
Depending on the difficulty of the task.
Well, it's a clean, perfect example of moderation, meaning that yes, it has a strong positive effect when the task is challenging. So the more experience, the better performance on difficult tasks. But the other way around, the more experience, the less performance on easy tasks. So maybe experienced employees are just bored when it's a very simple task and they're just, they're not trying. So, but you see a very strong relationship, but it's a very different relationship than, depending on this moderator. So sometimes moderator simply attenuates, makes weaker, stronger effect, but sometimes it literally reverses. And in this particular case, the effect is completely different depending on the moderator, if it's easy or difficult.
So you get more outliers, the more years of experience that you're looking at though. So do you still think?
Oh yeah, so the real answer, I don't know. I mean, as I said, I just kind of, I'm sure that's a made up data set and doesn't really, give you the answer to the question. But the point here is that if you didn't do the moderation analysis, if you just simply look at the raw data, it looks like there is no relationship at all, right? So, but only when you add that moderator to the effect, you realize, well, there is a relationship, but it depends on, and in your case, or in this case, the difficulty of the task. Again, it's just an example, but often the data themselves may look like a random cloud until you start parsing out those, moderator effects, so to speak, or the effect of the moderator. All right. Now, can you give me more examples based on your research of basically effects of moderators in your field? In fact, I extracted 3 examples from the previous proposals that I saw last week or this week that you submitted, but I'd like to hear more. So like, for example, one of you is working sort of on the effects of stress in the workplace on the workers' compensation claim. So it's a little bit more complicated than stress in the workplace, but let's assume that it's the variable. And so the student hypothesized that the effect would be positive here. So the more stress, the more likely the worker compensation claim will happen. But the effect is moderated in a way by the leader-member relationship, in a way that when the relationship between the leader and the worker is good, then the effect of stress on workers' compensation claim is lower. So here, basically the relationship between the manager and the employee moderates the effect of A on B. Another one was talking, one of the students here, who are, was looking at the effects of socialization on job satisfaction, and again hypothesized that it would be positive. So when workers, co-workers, employees socialize, then they will be more satisfied with their job. And the hypothesis was that the effect would be stronger if the employee has more autonomy, and weaker, I assume, if there is less autonomy. So, and then there was a very interesting proposal on the effects of working from home. Again, I'm oversimplifying here just for the sake of the example, but essentially the idea was that if you work from home, you will be less likely to be promoted. You probably will be paid less. So essentially, if you're staying away from the office and working from home, you don't have those same opportunities that employees who work from the office. But then the hypothesis was that pandemic may actually make this effect weaker, because during pandemic, more people work from home. So they have more experience and are more accepting of people working remotely. And because of that, those who will be working from home after the pandemic will not be as discriminated against as they were before the pandemic. So these are some of the examples that, even though you didn't have to talk about moderator effects, some of you included them. Any other examples, either based on your own research or just from your field? Oh, don't be shy, guys. Give me at least one or two more examples.
So I can use mine. It's a study about crisis response and using the cultural tightness looseness theory. And the idea was that if the company lets the local management team manage the crisis as opposed to managing it themselves from the home office, they would be more likely to have a shorter outcome. So I think I guess you could look at maybe the location of the team being a moderator, but I also think it could be elements of the crisis. Like if there was a fatality involved, that could also be a different kind of moderator variable. So when the crisis is different.
Your example with the fatality, there was this very interesting study, it's still one of the most influential, on so-called universalism, particularism. So it's one of the cultural dimensions, and it's our willingness to make exceptions or essentially lie on behalf of our, close people, kin, friends, relatives. And so the story goes like this. Imagine that you are driving in a car with your father, the father at the steering wheel and you are the passenger. And then a pedestrian jumps in front of the car and your father hits the pedestrian. The police arrives, and so your lawyer tells you that, so there are no witnesses other than you and the pedestrian. And your lawyer tells you that if you tell the police that your father was driving within the speed limit, then you will spare your father from a lot of trouble. And if you say honestly that your father was speeding, which was the case, then your father will be in a lot of trouble. So would you lie about the speed limit to save your father? Would you?
Yes.
No.
Raise your hand if you would.
No.
Really?
Okay.
I would.
So, okay, so about half and half.
I don't have a good relationship with my father, so no, he can.
Well, now, importantly, the situation changes a little bit. Turns out the pedestrian dies. So what if the pedestrian dies? So if before the matter was, will your father pay $250 fine or not? Now the question is, will your father go to prison for a long time? Or it is a serious issue. Not to mention that if you're caught lying in a serious matter like that, you will be in a lot of trouble. So now that the pedestrian dies and the stakes are much higher, would you lie or not? Again, I'll leave that question with you, but this question has been asked multiculturally in different countries. And so originally it was only the first part, would you lie on behalf of your relative to save the relative? But then they noticed that there was not really that much difference. But when they added this kind of severe condition, what if the pedestrian dies, all of a sudden differences started emerging. So in the United States, what was the difference? So if the pedestrian dies, are people more willing to lie or less willing to lie?
More willing to lie.
In the United States, it was actually less.
I would say
Really?
less.
Asian countries, it was more. So in the United States, they were like, well, if it's like low stakes, yeah, sure. But if it's a matter of, I'll go to jail if I lie, my father, like it's a big deal. So people would say, no, if it's such a big deal.
That's really heartening.
Yeah,
That's
and
good.
then in some other countries, it was the other way around. If it's a little thing, yeah, I guess I would. But if it's a serious thing, oh, now I definitely would, because it's no games anymore. So again, it was sort of, the fatality part was the one that changes how people respond to that same question. So the difficulty of the situation. All right, any other examples?
Voss, I have a question,
Yes,
if
go
you
ahead,
don't
please.
mind, on moderation. How do we know if you're testing a moderator when it adds to the, so the one example that you had earlier was the moderator, when it was present, would have a stronger relationship to our dependent variable. How do we know that's not just another variable that adds to the end result? How do we determine the difference between them? So it's, instead of it being a moderator, it's like, well, it has a direct effect itself. How do we know the difference
Just an
between the two?
This is a $1 million question. This is a very, very good question, Ben. Well, we will talk about how you test it, so if there is a moderator effect. But the truth is that the software never knows sort of the causality, so to speak, or the nature of the relationship. And so it's all up to you. So it's all up to you how you want to specify it. And the truth is that in many cases, you can do it any way you want. It can be, you know, A affects B moderated by C, or maybe it's A affects C moderated by B. And especially if all of them are significant, no matter which way you specify it, you may still get, you know, significant results. And so in most of the cases, that's the problem. That's why we always repeat that we do not establish causality in these models. We only say if this is what we hypothesize, the data supports or doesn't support this model. But, you know, to truly establish which one is the cause, which one is the effect, and which ones are the moderators, you would, I assume, need to do at least, you know, a few experiments. So this sort of is left up to us, and it's how we tell it, how we specify the model, that's how it is. Likewise, when you start adding controls, you know, how do you know if you have all of them or enough? I mean, or how do you know, like when you do the control variables, you have a bunch of variables, and so which one is the cause and which one is the control? Well, as I said, the math or the software that you use, it doesn't care. It just literally shows you how those circles, so to speak, overlap. It shows if there is an overlap in variance. But the actual relationship among the variables, that's the conceptual part. And that's why you often will see so many different variations, because you can piece it together in so many different ways. There are ways, you know, like for example, we'll be talking about structural equation modeling. You can map it, you know, like you can have the models mapped whichever way you want, and then you will see which one fits the data best. But it's still not a, you know, you can find the model that fits the data best, but it does not necessarily will sort of prove definitively that it's a moderator and not just another predictor. So, but yeah, that's the most difficult question, and that's the one that usually cannot be answered with any definitive sort of, you know, degree of certainty.
Got you.
So
Thank you.
Very good question.
So that's why you're always looking at the theory then
Yeah.
to support it.
Yeah, and that's why you always are supposed to be looking at theory. But in reality, what people often do, you know, they just try every possible combination and then present the one that gives you the prettiest p-values, right? So
what about when you have multi-level analyses, though? That's where I get really confused, because like the example that you gave us about promotion and someone that's remote versus in the office. I've been part of teams in banking where everybody was so toxic on the team that they say, so-and-so who's remote is going to get promoted. And everybody's like, what? They don't even in the office. But then when you did an analysis after the fact, they said, everybody's so negative here, they're positive. A positive person gets promoted over a negative person any day of the week. And so I think that's
so maybe you want to test for the moderating effect of the industry or the office climate or culture. And so maybe overall the effect is positive, but in some companies it's the opposite. As they say, usually, the more we interact, the more we like each other. But with in-laws, they say that our love to in-laws or for in-laws is directly proportional to the distance in miles between you and them. And so I remember my first couple of years, I was not really living with, but was relatively close with my in-laws. But for the last 20 something years, we're on different continents. Much more love now than when we were, nearby to one another. So, but then again, with friends, school friends, obviously, it was much more fun when we worked together. So it doesn't. So, but yeah, that's a very good example. And it could be culture. It could be, the specific circumstances. I read recently this book called Brotopia about the Silicon Valley. Apparently, at least in the 2000s, it was a very, I don't even know what to call it, the culture sort of not really masculine or patriarchal. I mean, there were a lot of sort of, peculiarities. And so the Silicon Valley at that time was very different, for example, from I don't know, Wall Street or, the Washington, D.C. culture. So very possible. All right, so now how would you test for moderation? I'll again give you a very simple step-by-step process. It's actually, there is really not much more to it, but there are a couple of articles that I assigned to you or suggested that you read that talk about it more in more specific terms. But briefly, you know, this is an old test from the 80s, I believe, if not earlier. So if you have the predictor X and the outcome Y and the moderator M, you just go through these steps. So you generate the interaction term. So that's your kind of key. So you'll have to create a variable that is literally X times M. So you add one more column in your Excel, or if you do it in SPSS or R or Stata, there are commands, and I'll show you those commands. And so you create one more variable, which will be your fourth variable. And then once you have it, so you test the basic model. Sometimes you also do this kind of intermediate model, and then you test the full model. And I'll give you the example of how to do it. So again, like for example, if you use Excel, let me show you here. I'll go to my collection of the data files that I prepared for you. I'll just show you the files. So we're talking about moderation. So so this would be my experience, that's the results, that's difficulty, and this one, it's literally one over the other. So you can see it's nothing more but just a product, right? And so this is the chart that it was supposed to show. I'm not sure why it came up with a different one. Must have linked their own one. So, but in any case, you literally just multiply it. And if you do it in Stata, I'll just show you as an example in Stata, but you can do it in all of those all of the software that you would be using have a command for that. So let me just open my Stata. So if I open the file, and you need to create, oops, I think I do it like this. So here is the file. So you would literally just write generate. So the command is generate equal, so generate, and let's say, for example, we'll create a variable. So we have difficulty on experience. Let's generate the various result versus experience. So experience, for example, times results. And it's equal experience times results. And it just doesn't like my name for some reason. Oh, I needed to add the variables here. I think it goes like this. Or no, like this. For some reason it doesn't like my name, but I wonder if that's because of this. I don't know. I'll
Is it extra space? You have an extra space before result. Is that a problem?
No, that shouldn't be a problem, but it seems like for some reason it doesn't like this name. So whatever, the name doesn't matter. So in this case, I guess it's, or maybe it doesn't need them. Should be. Oh yeah, so it doesn't need the quotation marks. Okay. Yeah, and so it just created the variable as you can see here. So it just created it right here. So depending on how complicated it is, I always prefer to create the variables in Excel. Gives me kind of visual check, but that's what you do. So your first step would be to create the variable, and we did it. So we created the variable. Then let's do the test the model. So let's test the basic model. And again, just as a brief show, so we will look at so we will regress the results by experience. And so this is your result, but I already pre-packaged it for you. So we will look at the outcome. So looking at the basic model, what can we say? Does experience predict, in our case, results? So our key variable would be this one, or key number would be this one, right? So, and maybe we want to also look at the R squared. So based on this model, what can you tell?
No impact.
Right?
It's not statistically significant.
Exactly. So it doesn't do anything. Now we also added the same model, but this time I added experience and difficulty. Anything going on here? So again, nothing significant. It explains less than 1% of variance, but nothing significant. But then I do the full model, and in the full model, I added the interaction term, the one that we just created. And so here we all of a sudden explain 74% of variance, which tells you right away that it's a made up data set. It's never that high. I mean, you're lucky if you see 20%, maybe 30. So, but in this case, it was obviously tailored to fit the model. And then you look at the coefficients, and all of a sudden, most importantly, the one that you're most interested in is the interaction term. So looking at the t-score, it's the strongest one. but also it's a positive relationship. So it tells you that when difficulty is high, then the effect of experience on performance is positive. And then all of a sudden your experience and difficulty become also significant, and in fact quite significant. So it looks like the harder the task, the overall people would be performing less. But if you account for the difficulty and experience, then the picture is different. But in this case, your key variable that you're paying attention to is this one, because the other ones are all very strongly correlated, and obviously there will be multicollinearity. So these indices are not that informative other than the interaction term. And so that's basically how you do it. Very simple, nothing too difficult, but you can do it that way. All right, mediation. So in this case, that's where you want to kind of test the process or the mechanism. So you, for example, hypothesize that emotional intelligence predicts peer evaluations. So you see that there is a relationship. You hypothesize that people with emotional intelligence get higher peer evaluations. Maybe peers like them more. Maybe they, do something that get those higher peer evaluations, and that's something you think may be communication. Maybe people with emotional intelligence are more likely to communicate frequently or communicate well, and because of that, so they're liked and get higher peer evaluations. So this is one way to specify the model, and sometimes it's specified like this. So you would say that emotional intelligence does correlate with peer evaluations. So there is a direct effect, but the indirect effect is via communication. So communication in this case is your mediator, or whatever that would be. So, being able to make a good impression management maybe, right? Bro culture is, previous one, I just saw the comment, that's exactly the one. So anyway, here is your model. And so the question is, how would you then test this model? Any suggestions for how can you test whether or not the effect of emotional intelligence and peer evaluations is mediated by communication? Anyone knows how to test this model? So as you can see here, obviously you can just look at the relationships among all three variables, and you can say that all of them are, related. But you're looking at a very specific type of relationship where, the effect of one on the other goes through the third one. And maybe in some cases is present only when the third one is present. So anyone? Again, there is a very simple step-by-step procedure. Again, I think it's from 1986 the first time, or formalized at that time. Again, if you have predictor, outcome, and mediator, here is what you do. So you first see or test or address if X predicts Y, or Y is predicted by X. Then you look if X predicts the mediator, or in some models they say mediator predicts Y, but actually you want to see if the mediator kind of relates to the predictor and outcome. And then you test the full model. Now, what you want to see here is if there is no direct relationship between X and Y, it is improbable that there will be a mediated effect. So more likely than not, there would be a direct effect. You just want to see if that mediator helps. But generally, you want to see at least some relationship here. It doesn't have to be strong, but you probably want to see some relationship. These are more, again, kind of preliminary checks, and you can skip this step. But usually, again, if the mediator does not correlate to anything, it probably cannot mediate anything because, according to your specification, it correlates to EQ and it correlates to PE. And so if in this step it's not correlated, it's very unlikely that there will be any relationship in the mediated model. But then ultimately, and most importantly, you do the full model, and this time there are no interaction terms. You only have your X and Y, and I think I mistakenly added mediator twice. Let me just correct that before I forget. So it's only plus mediator. So I added it twice, my mistake. So and let's try to do it. So here is your data set. And we want to know if communication mediates the effect of EQ on performance. And so we'll look at EQ on performance. Again, I made a mistake here, put CQ, EQ. So does it look like there is a relationship between EQ and performance?
No.
If you look at the cloud as a whole, it seems like there is a little positive relationship. It may not be visible, but I gave you the correlation here as well. So looking at the correlation, does EQ correlate with performance?
Yes, slightly.
Yeah, you have some relationship, right? 0.25. And then you hypothesize that communication may be playing a mediating role. Is it possible that it could be a mediator looking at the correlation table, a matrix? You cannot say, but at least you see that it correlates with both the predictor and the outcome, which is sort of a good sign. And so let's do it one by one. So first we do the correlation, and the regression analysis, just simply to see if your predictor, in this case, EQ, predicts your outcome, which is performance. And so this is the model. Would you say that there is a relationship? So your key numbers would be this one and this one. So based on these two numbers, is there a relationship or not? Effect.
Very small,
It
very, very
doesn't-
Yeah, it's pretty small.
Yeah, so it explains 6% of variance, and it's kind of marginally significant, so to speak. So it seems like EQ does correlate with or predict peer evaluations, but it's not a very strong predictor, at least based in terms of statistical significance terms. Then you do the next one. So yeah, you see. Then you do the next one just to make sure that that mediator correlates with your outcome, or in this case, with your predictor. And so when you look at the numbers, does it look like it plays any role or relates?
Yes.
Yes, so it seems like at least, it doesn't tell you much yet, but at least it's a good candidate. So there is a chance that it will come out as you expect. And so you have the full model here, and you look at the key numbers, and what does it tell you?
It explains 16%.
Yeah, so it explains a much bigger percentage of variance, but importantly, your mediator is also significant. And so one more important thing that you want to pay attention to, so when you look at the effect, so here, direct effect, when you look at the direct effect of EQ on performance, you see marginally significant results, right? But then when you put the full model here, right, your direct effect becomes completely insignificant. And so that's the case when they say it's a fully mediated model. So it means that it works and works only when there is communication sort of in between. So in this case, the indirect path explains much more, and direct path becomes insignificant. So in this case, it means that really your EQ works much, much better, and basically only when you have the mediator. So sometimes both of them remain significant, in which case you have a partially mediated model. So even when you account for the role of mediator, you still have a direct effect and you have the indirect effect. But in this case, once you account for both of those predictors, you see right away that the mediator, that's where they're all, that's where it matters. And so the direct path becomes basically irrelevant because it only works when people with emotional intelligence have a chance to kind of manage communication. Otherwise it wouldn't work. Like for example, if they have high EQ but don't communicate with their team, it probably will not help them. But only when they have frequent communication and can charm them with their high EQ, emotional intelligence, only then it would matter. So basically that's the idea. And yeah.
So in the earlier slide, you said that if there's no direct effect, like at the beginning, then there probably isn't. But isn't it possible that the indirect offsets the direct effect so that it seems like there's zero effect,
Yes.
but then when you have the mediator, it becomes that there is?
Yes, it's very possible. And it's sort of what we have here, because strictly speaking, even though we had a significant correlation, but when we did the regression analysis, I mean, if we take the 0.05 as a cutoff, we can say that there was no direct effect when only the EQ was the predictor. So in a sense, that's kind of what we saw. And again, in most cases here, it's not a really, clear cut. I mean, like in this case, I would say, yes, there is a mediation. I mean, obviously the mediation is going on. It seems like EQ by itself probably matters a little bit as well, but it only seems to me like it matters when you have that opportunity to exert this kind of, emotional intelligence charm. Otherwise it probably wouldn't work. But yeah, so that's why you have to go through those steps, because otherwise you will not, see the full picture. And sometimes you go through the steps and even then it's still a little confusing. You can interpret it one way or the other. But, in this case, it does look like people with higher IQ get better peer evaluations, but because and only when they communicate so that they can, use that as a mechanism to woo or to charm their peers. And again, in this particular case, it's not a real data set. It's, I assume it's a made up stuff, but it's to give you an idea of what the possibilities would be or types of problems would be. So in your case, it could be something very different, but you would still be following the same steps. All right, now let's talk about structural equation modeling, which incidentally can also be used to measure or to test this kind of model. So, oops, let me go back to, yeah, so like a model like this, that would be also done in structural equation modeling without those intermediate steps. But let's talk about structural equation modeling. So a sample question, research question for structural equation modeling would be that, let's say that I believe that socioeconomic status and IQ help people get into better colleges, which in turn then results in higher technical skills and better work ethics and more professional connections, which then helps them get better jobs, which then leads to higher income. So you have like a 5-step, logical chain. And so the question is this causal chain supported by data? So not you just saying that, socioeconomic status correlates with income, but you look at, this whole, story from your, what kind of family you come from, to what college you go to how you work, to what skills you acquire, to what kind of connections you have, what kind of jobs you get, and all the way back to how much money you actually make. And so another question is, what if I shuffle these factors around and arrange them in a different order? So maybe it's, if you go to better schools, you will have, or if you have better skills, you go to better schools and not the other way around. So would that be a better model or not? And that goes to Ben's question. So how do you know which one is the predictor, which one is the outcome? Well, one way to sort of test it is in SEM, you just specify it every possible way. You run the tests for each model, and then you see which ones give you the best statistics. In SEM, you don't use R-square, you use GFI and CFI. There are several coefficients, but they are sort of similar to R-square in a sense. They tell you how well the data fits, the model fits the data. And so by finding the one that gives you the best data, presumably that's the one that is, the best one, the best explanation. And so I'll give you just a few examples. So this one, obviously, you can have a whole separate course, but I just give you a few examples of models, SEM models from my own research. So this one was published last year. And again, you don't need to look at the specific variables here too much. The point here is that, you see like a relatively simple model. So you have a few things related to one another, like personality and international experience, predict performance and satisfaction. But then you also have some capabilities like cultural intelligence, IQ, and emotional intelligence that also mediate this relationship and then have the effects on their own. And you can specify them whichever way you want. And so that's the model we got. Here is another one at this time under review. So as you can see, that's a much more complicated model. I don't like this one. So I'm a co-author, but I'm not the lead author. And so when I see something like that, I usually get upset, meaning that it's like data voodoo, like everything relates to everything. I mean, this is uninterpretable. You cannot take something like this and go to the manager and say, do this and don't do that. I suppose there is room for models like this. And I mean, I'm on the paper that uses it, but I generally like simpler models where you say, A affects B, may be moderated, may be mediated, but not with 25 different things. So, but yes, the point here is that in structural equation modeling, you can have all of those relationships at once. You test them at once, and then you will get a coefficient for each of these arrows that are basically regression coefficients. Mathematically, it's still regression. And you interpret them the same way for every unit change in one. This is how many unit change you get in the other one, or for every standard deviation change in one, this is how many standard deviations change you get in the other one. And then you have overall model fit indices, kind of like R-squared, but you have, the general goodness of fit, partial goodness, like there are like probably like 8 or 9 of those that are used. And usually we look at like GFI and maybe a couple more, but it doesn't really matter in this case. When you do SEM, you'll still need to look it up. And so don't try to memorize everything. You'll still have a sample. And by the way, for the SEM, you have a very good chapter in your Tabachnik and Fidel book. Explains how it's used, where it's used, and gives you a few several real examples with the actual results right up. Now, talking about SEM, there are a couple of cool things that it can do beyond of simply, testing multiple relationships in a model. So one thing it does, or is very good for, is confirmatory factor analysis. Remember, we talked about it before, and so in this case, you have, variables related to constructs, related to types of constructs, and it works very, very well that way. So it would be a very convenient way to, that's the method to do confirmatory factor analysis. So structural equation modeling is, uniquely suited for it. And in this particular case, you see the regression coefficients for each of the paths. You can also add the significance, like the asterisks here, and then you know which ones are significant, which ones are not. And so it gives you all of those. But so here you have sort of individual variables and how they relate to the bigger constructs and then to the kind of second level constructs.
Does it work well when you have continuous covariates or when you actually have like categorical things that happen?
It doesn't matter, it works the same way. The only difference is that if you have categorical, if it's only two categories, then you have a dummy 0 and 1. So in that case, if it's significant, it means when it's 1, then this is by how much the effect is stronger. Like for example, if this was a categorical variable and you had a coefficient of 0.67, it means that formal correlates or affects institutional trust at 0.67 when institutional trust is 1. Or I guess it's not when, but it's by 0.67 points greater when institutional trust is 1 versus when it's 0. But if you have more categories, like let's say you have 3 or 4 or 5 or maybe 55 if you have many countries, then it becomes more complicated. Just like in the regression, you would have number of variables minus 1 dummies, and then you would have to put each of those in the model just like here. So it works either way, but usually once you have categorical variables with more than 2-3 categories, then you have a bigger set of dummies and it becomes a little bit more complicated. All right. So now when it comes to confirmatory factor analysis, also in terms of what software we use. So it's a little bit more specialized, so you wouldn't be able to do it in SPSS or Stata. So in my days, we used Lizrel, which is a very, it basically looks like MS-DOS. You have to type the commands. It's a little bit, the interface is not very user-friendly. So especially if you're not a professional. But then shortly after, must have been about 15 years ago or so, IBM Amos came out. So IBM makes SPSS now, and Amos is one of those. And that one is much easier. So you basically draw the picture. Like at the time when you're creating the model, it literally looks like if you're in PowerPoint, just moving, squares around. So you literally just draw squares, you specify the arrows with the mouse, and then say run the program. The only problem I have with Amos sometimes it doesn't like my data. So for some reason, sometimes it just doesn't want to read the data, or sometimes the model is specified, but something's missing. So it takes a little bit, sometimes everything seems fine and for some reason it's not working. And then you have to dig and then you realize that you forgot a little thing somewhere. So, but Amos is relatively easy to use. And then you can also do it in SAS. R now does it as well, but R apparently is not as advanced when it comes to SEM as, for example, IBM or Lizrel or SAS. So for what you will be using it, at least in the nearest future, it's more than sufficient. But if you want to do some high-tech stuff, apparently it doesn't have all of the possible tests and then, validations and whatever else needs to be done. All right. Now, finally, and most interestingly, the HLM. So HLM stands for both the method, hierarchical linear modeling, and for the name of the software that we usually use for hierarchical linear modeling. You can do HLM modeling in regression using what they call fixed and random effects models. R definitely does it. Stata allows you to do some things. But again, there is a dedicated software called HLM, and it does a very, very good job. And then I'm sure there are other ones, but HLM is still the most popular. And so the sample question would be, for example, let's say I assume that people with higher EQ get higher peer evaluations. And I assume that the effect is stronger in smaller groups. And going back to the comment somebody made about the toxic environment here. So maybe I also assume that it is generally true, but maybe the effect is stronger when the environment is toxic. So that's where you really have to have high EQ to kind of gauge everybody's emotions and adjust accordingly to that. And so I may hypothesize that the effect of EQ on peer evaluations is moderated by the characteristics of the group. So either the size of the group or the climate in the group, or maybe the industry. And so in this case, it almost seems like it's a case of moderation, but the difference is that we recognize that we're talking about the moderating effect of the group level stuff. So we have a bunch of individuals, but it's moderated not by individual characteristics, like work experience, for example, in the past example, or difficulty of the task, but by the characteristics of the organization. And that's where it becomes a little bit trickier. So you sort of have individuals nested within teams, and then maybe sometimes teams nested within organizations, and it becomes a little bit trickier here. Like, for example, in my line of research, one of the common issues is that we want to look at the effects of national culture or the national environment on firm performance or individual performance. And so the firms are affected, let's say, by the institutions, or are affected by ease of doing business in the country, or by culture, by national culture. But the firms I have, let's say, for example, 1,000 firms, and they come from 10 countries. And so when we look at about ease of, like, let's say, for example, data for ease of doing business, there are only 10 data points because we have only 10 countries. And so technically I can look at the location of each country, and by that location plug in the number. So I would then also have 1,000 data points. But in reality, it's not really 1,000 data points. It's 10 countries. So it's 10 data points repeated depending on the location of the country. And so it's a little bit different. So you have the so-called nested data. And so that's where it becomes tricky. And so I'll give you a couple of examples here. I'll give you first a real example that prompted the whole rise of the methods. So it came from education science, not from management. And so it was a very interesting, fascinating study. So now we will be talking about the real stuff. So like that's the real, it's not the real data that I will show you, but the conclusions will be exactly the same as in the real world. So the question I have for you, does socioeconomic status predict academic performance? So basically, do kids from rich families perform better in school? Like, for example, on the SAT. So does the socioeconomic status of parents affect the child's either GPA in school or SAT performance? SAT, for example, standard test.
Yes.
In which way?
It's a diminishing return.
Can you elaborate? So diminishing, so is it positive diminishing return, negative diminishing?
I think it's a bell curve. I think ultimately the very, very intelligent, the kids that come from very, very rich families would have not that great of an SAT, and those that come from very poor families would not have that great. I think because the rich family, they're working all the time to pay the bills and they're never spending time with the kid. But I think if you have someone in the middle, they would be better off and more successful on their SAT.
So you're saying that kids of Bill Gates, I think he has 2 daughters, is it? And
Two daughters, one son.
Yeah, and then you have, who else? Elon Musk, Jeff Bezos, who are the other super rich at this time. So their kids will not be as smart as kids of those who make, let's say, a good salary, but not filthy rich.
So you're saying that Paris Hilton didn't do well in her SATs, Jeff?
That's another one. That's a good example. So
Lori Laughlin's kids needed help getting into college, so.
well done.
well, so
Southern Cal too, man.
but
Come on.
if we're not looking at those extreme outlier examples, and let's say we assume a linear relationship. Yes, I mean, when it comes to income, it's always at the very least log, kind of diminishing returns, maybe not becoming negative necessarily, but maybe that, advantage of the socioeconomic status at some point becomes much weaker. So would you say that the relationship is positive or negative overall?
Positive.
Guess is positive.
Positive.
All right.
Positive.
Okay,
yes.
so let's take a look at the data. So here you have the SAT scores and the family wealth. Does it look like it's positive or negative?
Positive.
Positive.
Yeah, it does look like positive, and that's exactly what the study found first. But then they looked at the same data split by the school district. And this is what the data looked like. So each color is the district, different school district. What can you say based on these data?
Negative.
Or schools in this case, let's say, for example.
Within the district, the richer kids did worse.
So essentially what they found is that, yes, in the areas of the city were, affluent areas. So in the schools that are in affluent areas, the kids show better results. So if you go to a rich part of the town, those kids will do better than if you go to a poor part of the town. But within the school, within the same classroom, so to speak, you will see that kids actually from poorer families do better than kids from the richer families. And so what you have here is you have multi-level effects. At the level of the school, you have a negative relationship. But at the level of the school district, you have a positive effect. And so at the individual level, it basically means, shows you a negative effect. But at the level of the school districts, so essentially the best kids are the poor kids in the rich neighborhoods, so to speak, or relatively poor kids in the relatively rich neighborhoods. And so those are real data, or real finding at least, these are random data points here, but that's exactly what they found. And so as they were trying to figure out how to analyze it, they came up with HLM as the methodology, and then those same guys wrote the code and basically wrote the software. And so it's actually relatively recent. It's like we're talking about 20, 30 years ago. So relatively recent stuff, recent developments. So I'll give you a few more examples of how, and again, obviously we're not going to get into the actual, how to use the software, how to use the method. I was able, so I didn't take a dedicated course for this, but my dissertation is based on HLM. And I'll give you a couple of examples in a minute from my own research and including dissertation. And so what I did was I bought a couple of textbooks, and then I, spent maybe 3 weeks, I guess, maybe nonstop reading the text, playing with the data. And the textbook, by the way, came with a CD at that time that you could download the data set. And so I was playing with the data set, got the software. They had HLM for students. You could use it for free up to, I think you had like a limit of 2,000 or 3,000 observations, something like that. And you had a limit of how many groups you can have. I think there was like no more than 100 groups or something like that. So there were some sample size restrictions, and I don't remember if I got it for free, the full version from the school, but I remember as I was reading it, I was playing with the kind of student free version. And so in a few weeks, I became pretty comfortable with that. So there is really nothing super difficult. In a few weeks, you can become pretty good with it. And so here are a few examples of like some of the stuff that I did, for example.
About that.
Yeah, go ahead, sorry.
If you get something like that and you have something that makes sense, it's theory based, and then you look at it differently and it makes a lot of sense. How do you know you're done then? I mean, how do you know that there isn't another way to look at it, that this is actually as misleading as the last data was? You just haven't figured out the other, piece.
Again, another $1 million question. The truth is, they're talking about this replicability crisis. They say like 85% of the studies cannot be replicated, from which we assume that 85% of the people, researchers, either got it wrong or didn't see something or didn't finish it properly. I guess you never know, just over time, as more and more studies accumulate, you start seeing that, well, this always replicates and this virtually never. But yeah, I'm afraid that there is really no I'm reading a book about entrepreneurship. And so this guy, for the first time, somebody honestly talks about how sort of startups work. Because in most of the cases, you hear the story of, Mark Zuckerberg or Bill Gates went to school, dropped out of Harvard, became millionaire by the age of 25. Everything nice and clean and A affects B. And, as long as you do these simple 7 steps of successful, habits of successful people, you will be successful. In reality, it's messy. It's never, like if it worked in one case, it will not work in the other. And in some cases, you don't even know if you got it right because you did that, or you just got lucky, or, like I just finished Business Wars this morning, actually. And then started reading that entrepreneurship book. But Business Wars was like two series back. So about a month ago, the last one was about SpaceX versus Blue Origin versus Virgin Galactic. And so Elon Musk, everybody loves him now and admires him. And, everybody says, well, do like Elon and you'll be successful. But the dude was literally on the brink of bankruptcy with both companies in 2008, I believe it was, Like literally everything was wrong for Tesla and everything was wrong for SpaceX. And they were literally just hours away from bankruptcy. And so like in SpaceX, they had 4 consecutive explosions of the rocket. And so had it been one more, we wouldn't know what Elon Musk is. Like the guy would be just a failure. And so obviously today he will come up with all kinds of theories why they succeeded. But the truth is, you know, it was just basically a chance at that point. And so, you know, luckily for him. Likewise, I remember I really like this, if you remember the old movie called The Pirates of the Silicon Valley. Have you seen that one? Or if you read the Bill Gates story. So you probably know that he sold his MS-DOS before he actually had it. So they sold the software where they didn't have the software, they didn't have anything. Then they bought the software, they tweaked it a little bit, and then it actually worked, and everybody's happy. And now everybody says, "Oh, how great he is! He dropped out of college, he created this company." Well, somebody was trying to do exactly the same thing, and her name is Elizabeth Holmes, and she too didn't have the product and was pretending that she does have that. What is it? The lab, whatever the name of that thing was. And so maybe if she had a few extra months, maybe they would have come up with a solution and she would have become the next Steve Jobs as she wanted to be, or Bill Gates in this case, I guess is a closer analogy. But no, unfortunately, the fact that she didn't have a working product became known a little too early. And now she is basically a poster child for, dishonesty in the Silicon Valley and wherever else she was doing the business. So yeah, so in many cases, you don't know, I guess. You hope to get the right p-value so you can publish the paper, and then at that point you pretend that you are done, and sometimes you cannot touch the topic anymore because you're so exhausted. So yeah. Anyway, here are a few more examples of HLM. So for example, for my dissertation that I talked about some time before, so I was looking at what predicts how fast people acculturate after immigration. And so one of the variables that I looked at was, obviously time. So the longer you stay in the country, the more assimilated you become. But one of the variables was how many immigrants from your country are in the city where you live. And so I had multiple communities, so I was able to look at that characteristic. But the problem is that the number of immigrants from your country in the city is a city characteristic, not your own characteristic. And so that's why I had to use HLM. And so I was looking at the effects of the community in which you live on how the time you spend in the country affects your assimilation. And so I found that in cities where you have a lot of immigrants from your own country, you assimilate much slower than in the country where there are few or none. So like, for example, here in North Carolina, there are no other Ukrainians. At least I know one family, but they're somewhere in Reidsville. So it's very hard for me to stay close to my Ukrainian roots because, there is no Ukrainian, church, no Ukrainian store, no Ukrainian Sunday school for my kids. So obviously assimilation is much faster. But in Canada, there were a lot of Ukrainians. In fact, in Canada, in Western Canada, especially, Ukrainian was the second most spoken language. And at some point, they even thought about making Ukrainian the second official language of Canada. I think at that time it would have been a third one. So obviously you can stay Ukrainian there for your whole life and never have to speak English at all, or at least many people survive without speaking any other language than Ukrainian. So, but in this case, we're talking about characteristics of the city in which individuals are nested. And so HLM is a better way to account for that city characteristic migrating effect. And so that was a bigger model. So sort of individual characteristics affect your values, but also country characteristics or city characteristics affect your values. Oh, that's a different study. Sorry, that's a different study. So here again, we looked at how your values are affected not by the color of your passport, but by things that like your gender, your socioeconomic status, your education level, age, and things like that, but also by the characteristics of the country. And here are a couple of examples. This one I found very interesting. So generally, the more educated the people are, the less power distance oriented they are. But we found that in countries that are very high on power distance, the more education you have, the more power distance oriented you become. So essentially, we're talking about the indoctrinating effect of of education. So if you're in a country where low power distance is valued, the more education you have, the more low power distance you become. But if you're in a country where high power distance is valued, then the more education you have, the more power distance you become. And then we also looked at the role of gender on power distance. And again, in countries where gender roles are not very differentiated, like for example, in the United States, where roles of men and women are not really that different, or at least it's perceived that women can do everything men can do. So in those countries, there was not much difference between values of men and women. But in countries where there are very strong gender roles, like, maybe in some Middle Eastern countries where women and men are treated very differently, the values of men and women were also very different. So you have these national characteristics affecting the effect of the individual characteristics on individual values. Now, and this is very important, the truth is that HLM is basically new regression, at least for organizational science. So for most of us, for most of you, you will probably more likely need to use HLM than regression. Because if you do research on business, it doesn't matter if it's HR or B type of research, or if it's more kind of firm level research, you probably deal with nested data. So you probably have people within teams, or people within companies, or companies within industries, or companies within regions, or companies within countries, or products within companies, or stores within store chains, or investments within investors, or specific actions within investors. And so what you find in many cases that you have that nested data. And when you have the nested data, regression does not necessarily recognize that. Plus your data set may not even be structured in a way that is suitable for regression. And so HLM would be and is more and more frequently used, and probably even more, or at least as frequent now as regression. And so in good science, at least for me, hardly any paper I write these days, a regression would be more suitable than HLM. So in fact, most of the papers now that I do would be more HLM based than regression based, unless it's something completely different. And so a couple more examples of what
I have a question
yes.
on that before you move on. So in what case would you choose HLM versus using industry as something like a moderator?
Well, it's not, HLM specifically allows you to look at what they call level 2 or level 3, if you have multiple levels, either predictors or moderators. So in this case, it doesn't really matter if it's moderator or predictor. The point here is that if, let's say, you have people within companies and you have multiple companies in your data set, then you have, let's say, 50 companies and then 50 people within each company. So if you wanted to know if the characteristics of the company affect that person's behavior or attitude, then you either have company level predictor, or if you wanted to see if that company level predictor affects the individual level relationships, then you have company level moderator. So you have level 2 moderator. And so you can do it in regression technically. But as I said, because you have only 50 data points for describing the company characteristic, and you have, let's say, 50 times 50, you have 2,500 people in your individual level. So you have sort of 2 data sets, so to speak. And so in a sense, what you can do, let me show you here. Let me just share screen.
I was thinking more simply just the company versus industry piece, because if you have even a simple analysis where you were looking at industry as a moderator, it sounds like it's always better to do it with HLM.
No, yeah, in this case, as I said, it's not so much whether or not it's a moderator. So you can, specify it as a moderator in HLM and regression, doesn't really matter. The point here is which tool you use to test that moderation effect. And so let's say, imagine you have a situation where you have people, person 1, person 2, person 3, so that's the person's ID, or let's say, for example, age, whatever that is, right? And then you want to see if that person's, let's call it age, for example, right? And then you want to see if that age affects, let's say, for example, performance, right? And so you have performance, whatever that number is. Again, let's say 1, 2, 3, 1, 2, 3, and so you have performance, right? But then all those people, let's say 61 people, let's say they are in 10 organizations, or I don't know, let's say not 10 organizations, for example, let's say 3 organizations. So organization 1 is small, organization 2 is medium, and organization 3 is large. And so they come from 3 organizations. And so technically you can add organization like this. So you add organization to your data set, and you say, okay, these first whatever number of people, they are from organization small. And then the next whatever number of people, they are from organization medium, right? And then, and then another whatever number are from organization large. And the problem is that this is wrong to do it this way. So even though you kind of created whatever number, 61 observations, but this is wrong, because here you have age, that's a personal characteristic. Performance, that's a personal characteristic. So whatever the performance is. But organization, that's not a personal characteristic. It's an organizational level, characteristic. And so in this case, you are cheating. And by doing so, your coefficients, it's not that there is something fundamentally wrong with that. It reduces your significance levels. The estimates will not be very correct. And so you may skip, maybe there is, but you will not be able to see it. So a proper way to do it would be to have these two variables. Then you would add the ID. So you would add ID. And so it would be, person's ID 1, 2, 3, 4, 5. And then you will create a whole separate data set right here, where you will have, again, ID, and you will have the size of the company. And so you will have only 1, 2, 3 companies. You will have size company 1, small company 2, medium company 3, large. And so here, for the ID, you will have, that basically becomes your ID. And so by linking these two data sets, and in HLM, you literally have two data sets. You will have level 1 data set, level 2 data set, and if you had like industry, for example, it would be level 3 data set. And so in this case, the program then knows, okay, that's personal characteristic, that's personal characteristic, that's the company ID, and this is the company characteristic. And then you can have, in addition to size, you can have maybe industry or whatever else it would be, company characteristics here. And so in that case, it will recognize it, it will provide more accurate estimates. It will give you much nicer graphs and everything else. And so, and that's the proper way to do it. So, a couple more things that are really cool things that you can do with HLM that you wouldn't be able to do with other programs. So one, you can do longitudinal analysis. In this case, your time points, like for example, this model, you have sort of time points nested within people and people nested within groups. So let's say, for example, somebody did something, 10 times or 20 times, maybe quarterly performance, or maybe, I don't know, whatever the, happens each month or each week. So in this case, you don't need to do time series analysis. You just have all these time points, action 1, action 2, or week 1, week 2 action nested within people. Then people are nested within organizations. And you basically run it as HLM, even though you're kind of running multi-level, running time series analysis. So a very nice way. And again, it produces very, informative graphs, charts, gives you very good, interesting information. Another thing that I always wanted to do a study and never had one that would be suitable, in HLM, you can use variance, group level variance, either as a predictor or as outcome. For example, you can look at how differences within the group. So not the group average age or group average emotional intelligence or group average GPA or SAT, but differences within group either affect something or are predicted by something. And so that's kind of neat. You literally will be using like standard deviations instead of averages for the group for whatever, characteristics you want to use. Again, I find that fascinating and just never had a study suitable to use this method, but always wanted to. So again, something that you couldn't do in most other software. All right, so that's all I wanted to say about the software. I have a couple more, about the methods, a couple more things about the next assignment, but I don't know, any comments, any questions about it so far?
So this is a new software package you have to learn then, HLM?
Yes, well, as I said, you can also do it in R if you know R. So there are plugins and you can do pretty good level work. Stata now has some plugins, so you can do some things there as well. The problem is that it will take you some time to figure out and to learn sort of what indices are reported, how to interpret them. Like for example, HLM does give you something that looks like R squared, but it's a little bit different. So it's not variance explained per se, but it's additional variance explained beyond sort of a zero order ANOVA. So it has slightly different explanations. SEM, for example, you also have, as I said, like 10 different or 8 different goodness of fit indices, and they need some. So what I mean is that you'll probably spend more time on understanding the logic behind the method and how to interpret the results than the actual software. The software is easy. You just basically, look at the guide, how to plug in the file and then how to select the variables. It will be very similar to whatever software package you use. The challenge is to understand the logic behind it and to interpret the findings. So the software themselves would just, you say, okay, this variable is my dependent variable or my level 1 variable. These are my level 2, run. So that part is easy. So it gets more complicated when you get in the actual sort of, interpretation. And again, so this one contains some guide and some examples, and I gave you a couple more additional articles. So if that's what you'll need to do, you will be, as I said, like, for example, I needed to learn that whole methodology for my dissertation, but it served me well ever since. The dissertation was good. I published a paper based on the dissertation. In fact, several of them, but one was specifically based on HLM. So, and it took me, yes, a couple of weeks, maybe 3 weeks, but it wasn't really that bad, and it was totally worth it. So, all right, anything else? Then let me talk very briefly about the next assignment. And we will, let me share screen here. And I mistakenly put study 2, but it would be 4, right? So it's study 2, yeah, it is study 2, but it's assignment 4, because the first one was data, right? Then we talked, first one was hypothesis, the second one was data, then study 1, where you talked about differences or associations. So this would be your sort of study 2 design that you need to produce. And this time, just to make sure that all of you follow, complete the entire work. So you need to do both, one on moderators, one on mediators. You can, in fact, half of you, it seems like, had moderators already in your data set. One thing, by the way, interesting, that most of you, it almost looks like almost all of you wrote your study design for hypotheses that are different from what you sent before, which is fine, no problem at all. You can have a different research question, completely different research question for each of the assignments. One was very interesting. What was that? There was one about, what was it? Gambling something, not gambling, how many people die in Batman movies, depending on how many gadgets Batman has or something like that. Interesting, funny. I'll actually use that example maybe, when making up my data sets for examples in the future, but it's very different from what the original assignment or set of hypotheses was. So it doesn't matter to me if you change them each time, so no problem. The only thing that—
Yeah, that was absolutely me.
Okay, then yeah, so I thought that was brilliant,
y'all know me pretty well now. Yeah, that was absolutely
the problem with that, Ben, is that if you stuck with the same set of hypotheses, you would kind of develop it more and more and more, and hopefully by the end of the paper, of the study, of the course, you would have a paper. But now, since you changed your topic, you kind of have two half-finished things. So you have one with good hypothesis, another one with a good, nice example of, association differences. But now you sort of disperse yourself, and you will end the semester with 5 very raw study ideas. And so that's fine, no problem for the course. You'll still get your—
I was feeling punchy that day, and I felt like
that's fine. Yeah, and you can probably just use different names of the variables, but it would be so no problem. But if you stick with the same set of hypotheses, and then you think, okay, well, if I'm looking at, for example, how stress affects the payroll, what was that, the compensation claims or something like that. So now you think, okay, well, what could mediate it? Well, maybe it could be, I don't know, job satisfaction. What could moderate it? Well, maybe it could be moderated by, I don't know, the person's work experience, or maybe by the organizational characteristics or something like that. And so if you sort of add all those different layers, by the time you're done, you sort of have thought about it so many different ways that you can now, yes, start writing your dissertation. And you already have quite a lot of stuff, and hopefully my feedback is somewhat useful here. So, but yes, if you want to change your topic, either because you're now interested in a different study, or just because you have this good idea for this specific assignment and you don't want to, spend too much time on it, that's fine. So, but anyway, for the moderators and mediators, please restate your hypotheses. So I know if it's the same one or if it's a new one. And so I don't have to open the previous study. And for some of you now, it's, different hypotheses and different submissions. Then ideally you want to draw the diagram. And again, it can be similar to what I had here, 1 level, or it can be something more like 2 levels. Where is this one? So where you have, individual, but the level 2 moderator. So that's fine as well. So you draw the picture that shows how your things are correlated with one another. Then you briefly talk a little bit about the data, just so we know what the variables are. Again, if you stick with the same data proposal, study proposal, I probably by now know what kind of data you're working with. But if it changes in any way, or if you added a new mediator, I want to see that what kind of data? Is it a continuous variable? Is it a categorical variable, percentage, frequency, something else? And then you describe the method more or less step by step. So for example, for the mediation, let's say you use OLS regression. So these are the 3 steps you'll do to test for the mediator effects. And these are the 3 steps you'll use to test for the moderator effects. And maybe even add, okay, I want this to be significant, but this not significant. Or this to be significant in the simple model, but become insignificant once mediator is added, or something like that. And again, so this way I will see your full sort of sequence, the full study design. But also if there are problems there, then I will be able to comment on that so that, before you start collecting your data, maybe it would be useful, so that way you'll get some useful feedback. And if you are planning to develop that into your dissertation, then yes, now is the time to discuss it. Now is the time. So the mistakes now are very cheap, but it will save you time down the road.
Are you fine if we use actual numbers from the data?
Even better, as I was saying, that if you continue working on the study that you wrote either for my course or for Aaron's course or for Aisha course, and you already have the data, I think there was 1 or 2 submissions that actually contained the data. And so, yeah, sure. In fact, if you already have the printouts of the results, I can look at those and, maybe even have some useful comments. So as I said, the goal of this course is not to teach you new methods per se, but to make sure that you can select the correct method and design the study around that method. And so as I said, in my perfect vision for this program was that in my course or Moses's course or Rika's course, you start developing your theory. Then in Aaron's course and Aisha's course, you start kind of running numbers and writing something based on that theory. And then by this course, you already kind of have it, but you still need some, you started using, let's say, regression, but you think, well, maybe I have multi-level data, maybe HLM would be better, but I'm not sure. And do I need to check for this or that? And so that's where we work out those little things. And so hopefully you end this course essentially with everything ready for your analysis. Like your research design is developed, you know exactly what measures you will use, you know exactly what methods you will use. So once you get your data, if you don't have them yet, you're ready to do it. Or if you already have the data, you just rerun it with the proper method because now you realize that there is a better method to do it. And then you basically are done with your dissertation. Now you just have to write it up and submit. So I know that in the real world, it probably will be a little bit different and it will still take some time before you have the actual dissertation, but that's the idea how it goes. And even after the course is over, so please feel free to come anytime back if you need advice on specific methods, either how to use it or if you're not sure which method would be most suitable. All right, so I think that's what I wanted to cover today. So if you have any other questions.
I just have one more quick question. Can you remind me or us how much theory or lit review type stuff are we going to have to do for this particular class when we submit the final paper?
For this one, not at all. Like,
okay.
I mean, I encourage you to include anything and everything you have, including your introduction, including your literature review. If you have theory, I'll be happy to read it and comment, and hopefully, like even if I just correct a few commas, hopefully it will save you some time down the road. I'll definitely read it with great interest and try to comment on everything. But the only thing that I really care for this course is the methods. So, the description of what kind of data you will use, what kind of analysis you will use, basically, step-by-step explanation. So it's good if you include the method in literature review just so I better understand what the study is about. But, and then obviously I want to see the theory, at least in the form of hypothesis, so that I can determine if the method is correct. But otherwise, I don't really need that part other than if you have it, show it to me, I'll be happy to comment.
Okay, thanks.
Yeah. And you cannot lose points for having a bad literature review or theory, because that's not part of the course. So we already had theory, this is a different course. All right, well, then good luck. And so I think you have 2 weeks or something like that for this next step. Don't kill yourself. As I said, it doesn't have to be too detailed. You just need to think if I needed to add a moderator or mediator to my model, what it might be. And again, maybe it's already part of your model, maybe it's not. Maybe you will not use it in the final model, but it's good to think about what it could be. And if you did have one, how would you test if there is a moderation or mediation effect? All right, well, good night. And I'll see you in a couple of weeks then. Bye.
Thank you, Voss. Good to see you, everybody.
Bye.
Good night.
Thank you.
Night.